So in this video, I thought I would give a explanation of stoichiometry that is more intuitive than what you might typically be presented with in class. Because a lot of times I see students come to me as a tutor in the first couple weeks or couple months, and they did poorly on a test, they did poorly on an assignment. And almost always, the issue is at least in part because they didn't quite understand stoichiometry. I think one of the main reasons that students have trouble with stoichiometry is that it's not very well motivated. You're told that you have some amount of unit X, maybe 2X, and you want to get this into its corresponding amount of Y, right? Like if I have 2X, how much Y do I have? And all you got to do, your professor might say, is multiply your 2X by your conversion factor, Y over X. And that'll give you your number in terms of Y. So that would be 2Y, right? And that's all fine and good, like, sure, but where did this come from? Why is the conversion factor what it is? Why not 2y over x or y over 2x? Or some students get it screwed up and they'll accidentally do x over y. But if the conversion factor itself isn't motivated well, making mistakes like these is very easy. And even making mistakes like these, even though it would result in 2x squared over y, become very easy because you don't really understand why this is here in the first place. So I thought I would break it down in a bit more of an intuitive fashion and then see if we can scaffold on top of that the more complex and abstract units you'll see in chemistry. So how about we think of going to the store to grab some eggs? You've got to grab 24 eggs from the store. So you run to the store and they have eggs in cartons, 12 eggs to the carton, 12 eggs to the carton. And you go ahead and you grab 2 cartons. You don't think about it. You don't like do any math. You just know that you got to grab 2 cartons. But why is that? And maybe if we can understand what brought you from the eggs to the carton, we'll also be able to bring you from any abstract unit to any other corresponding unit. Because this logical jump is very intuitive for students. But a lot of times, for example, going from milliliters to grams in the constant context of a given concentration, it's like two different worlds. But this and this are the same thing. You're going to do it in the exact same way. So let's walk that through. Let's see why. So what are your knowns? You've got 24 eggs that you need, and 12 eggs are in 1 carton. If 12 eggs are in 1 carton, and in your specific instance, you're worried about eggs, you're thinking about eggs. For your context, you could just say that 12 eggs and 1 carton are the same thing. Because sure, yeah, the carton has, I don't know, it's made out of cardboard and it has a nutrition label on it. And then the eggs are in the carton, but there's more to the carton than just the eggs. So it's not like a carton just equals 12 eggs. But for what you're worried about, which is the eggs, if you say, I want a carton of eggs, or you say, I want 12 eggs, you're saying the same exact thing. Or if I tell you, bring me a carton's worth of eggs, you'll bring me 12 eggs. So for that, if we write 1C over 12E, assuming we're talking about number of eggs here, we're really describing a number, carton, over itself in a different form. So up here, we have eggs in one form, and down here we have eggs in a different form. They're just two different ways of writing the same thing. And since we know that 12 eggs corresponds to 1 carton, this number up top, this carton, and this number down here, these 12 eggs, they equal each other. So carton over 12 eggs would equal 1, or 12 eggs over carton would also equal 1 because you're taking a number, dividing it by itself. It's just itself in a different form. So either way, you're deriving some form of 1. So what happens if we start screwing around with our 24E over here? Let's see, 24E times 1 equals 24E. So we're allowed to do that. We didn't break any rules by doing 24E times 1. But if we look over here, we've got two different versions of 1 in our toolbox. We just figured out that 1 equals C over 12E, and that 1 equals 12e over c. So there is no real difference between multiplying 24 times 1 equals 24e, or 24e times this or this, because these are equal to 1. So let's plug in both of them to this expression just for the fun of it, because we probably know which one's going to be better, but let's just plug in both. So we'll start with this one up top. We'll do 24e times c over 12e, and that will give us 2 cartons. Eggs will cancel. 24 divided by 12 is 2. And that's exactly what we arrived at earlier. You went to the store and you grabbed 12 cartons. And how you could figure it out with stoichiometry is just by multiplying your original quantity of eggs by 1. And just for completion's sake, let's multiply by the other version of 1. 24e times 12e over c. That will give us 288 e squared divided by c. So technically, in your context, 288 eggs squared divided by cartons and 24 eggs are the same thing. But if you went to the store looking for 288 eggs squared over cartons, I don't know what store you're going to go to, but you're probably not going to find them anywhere. So both of those are correct ways of saying. You could say 24 eggs, or you could say 2 cartons, or you could say 288 eggs squared over cartons. And all 3 of those will be saying the same thing. And you can just pick which one you decide to work with based on what's the easiest. So in your case, the 2 cartons is what you're really looking for here. And that is really all stoichiometry is. You are just going to look in your specific context, and you are going to see what variations of 1 you can multiply your original quantity by, original, to give you that same quantity but in a different form. New form of the same quantity. 24 eggs and 2 cartons, in your instance, are really talking about the same thing, but they're just 2 different forms of the same thing. And if you want to bridge that jump between them, you use these versions of 1 up here, this and this. And these are your conversion factors. That's all a conversion factor is. So let's maybe bring this home with a more concrete example, a more abstract example. Let's say that you have 2 liters of a solution, and that solution has 3 moles per liter. And you want to know how many grams you have of solute if 1 mole of the solute equals 2 grams. There's 2 grams of solute per mole, right? The molar mass is 2 grams per mole. So let's see if we can figure that out. Let's move this over to give ourselves a little bit of space. And feel free to pause the video and see if you can figure it out before I walk through it. Okay, I don't think that's going to work, so we'll just erase that. What we'll start by doing is realizing that 3 moles per liter is really saying that in our solution, if I went and I grabbed out 1 liter, I took that out, and it's just hanging out over here, little puddle. There is going to be both 1 liter of solution and 3 moles of solute. So in our instance, 1 liter of solution and 3 moles of solute, when we're talking about solute, are really the same thing. If I tell you, go grab me 3 moles of solute or 1 liter of solution, either way, I'll end up with 3 moles of solute. And given that we are worried about solute, we're trying to find the number of grams of solute. That's the only part of this that we care about. We don't care that, yeah, a liter of solution is also going to have water in it because we're only worried about moles. We're only worried about solute, rather. So in that instance, we can really say that 3 moles of solute divided by 1 liter of solution equals 1 in the context of moles, in the context of moles solute. So let's go ahead and multiply by that 1, because you can multiply by 1 all day without changing anything. So we'll do 2 liters times 3 moles per liter. And that will cancel the liters, and we'll be left with 6 moles. Now earlier, I said that the molar mass was 2 grams per mole, and we're interested in how many grams. Well, again, 2 grams, if I tell you, go grab me 2 grams um, of that substance, or I tell you, go grab me 1 mole of that substance, you will bring back to me the same amount of substance. Either way, it doesn't matter which version I instruct you with. If I tell you grab me 1 mole or 2 grams, you'll bring back the same amount. So because of that, in the context that we're talking about here, 2 grams and 1 mole are functionally equivalent. So 2 grams over 1 mole are going to be equal to 1 in our specific instance. In our instance. That said, we could multiply by this 1 and not break any rules. We're still not breaking rules because we're still multiplying by 1. So let's take 6 moles times 2 grams per mole, and that gives us 12 grams. So that tells us that in 2 liters of solution, there are 12 grams of solute. So let's recap. All stoichiometry is doing is you are taking a series of functional ones. When you hear the word conversion factor, you're just thinking of, okay, in my instance, talking about the thing that I'm talking about, how can I make there be an equivalent of my underlying thing in the units that I do want over an equivalent in the units I have? And once you can find that, because they're equivalents in your context, dividing an equivalent by an equivalent is the same as just having a 1, right? So if you multiply by that, you're just multiplying by 1. And the lucky thing is that since the units you have should be up here, units have, they are going to cancel with these. And then this number, and this unit are going to be what you are left with. And you're just going to keep doing that sequentially until you get your answer. So you'll take units x, and then you'll multiply them by conversion factor between y and x, multiply that conversion factor between z and y, and then you'll end up with units z in the end. So you'll go from x to z, and you can do this for any units. And all you're going to be doing is sequentially multiplying by these conversion factors.